is day 6 today in pre-algebra. It is Wednesday. 4. And for the do now today, I just wrote some instructions up here. I said yesterday we took the Unit 1 quiz, and I set a timer, let you guys use that time to finish your quiz or make corrections. And then I gave us a few little equations here to give you a sneak peek into what we're learning today, because we are starting a new unit today. So we'll come back to these problems. But for now, I want to introduce you guys to Unit 2. So whenever you take your notes in, let's get that out. If you use your notebook, or if you need a notebook, there's plenty of notebooks up at the front of the room in that wooden shelf. And feel free to take whatever you need. But I'm going to title this Pre-Algebra. How we are Unit 2. Our second unit. This will be page 1 of our notes. Right. And the little title that this is day 6 notes. Guys. Some of what we talk about today will feel like a bit of a review, because before we took the Unit 1 quiz, I did teach a little bit of this to you. So it should look a little familiar. But Unit 2, we are learning now about equations. Equation. So we talked previously about how an equation is a bunch of numbers. Usually there's a variable in there too. And it always has an equal sign. That's our equal sign. So I am going to give us an example of an equation. Let's see. It's going to be just like what I wrote on the do now. That first one I wrote was 2x equals 12. 2x equals 12. And when we solve an equation, we're trying to find what number can I put in for the letter x that will make this true. So I'm trying to find 2 times what equals 12. This one you might know off the top of your head. Does anybody know what number would make this true? What number would be x? Do we know? 6. 6, because 2 times 6 equals 12. So it gets a little trickier when we don't know it off the top of our head, especially when we get into bigger numbers. So we're going to make sure that we practice the proper technique for solving an equation. What we really did is I saw that 2 times x equals 12. So to get x by itself, that's our goal. We want to get x equals a number. I need to get rid of this 2. So to get rid of this 2, we're going to use the opposite operation. So since this is 2 times x, what would be the opposite of times or opposite of multiplication? Division. I'm going to divide by 2 on this side. And if you guys recall, we talked about how an equation is kind of like a balance system. If I divide by 2 on one side, yes, I got to do it to the other side or else they're not balanced. So if I divide by 2 here, I need to do it here as well. Divide by 2. And after I write what I'm about to do, we draw a big line underneath. And when I divide by 2 over here, the 2's will cancel out and I'll be left with x by itself. I'll bring down my equal sign. And now all that's left to do is 12 divided by 2. And 12 divided by 2, just like you said, is 6. And so we just solved an equation. Just solved an equation. Okay. So before we start doing all the other ones, I know I taught you this, but I want to kind of reteach it since I know not everyone was there for that lesson, and it was a while ago. So at your tables, we have sticky notes at the bins. Go ahead and get yourself a sticky note. There should be in those rectangle colorful bins, pad sticky notes for each of you. And we are going to rewrite, you might already have this note, but we're going to write it again. When we solve an equation, we use what is called inverse. Inverse operations. Now, you might already have the sticky note, so you don't have to write it again. Does anybody remember what inverse means? Opposite. Inverse means opposite. So what we're trying to figure out is the opposite of each of the things we can do to numbers or operations. So first we have, let me get my colors. That's all. Okay. We have addition or plus or add. And what would the opposite of addition be? Subtract. Add and subtract, those are opposites. Other set of operations we'll worry about today are multiplication. And what's the opposite of multiplication? Division. Good. So addition, subtraction, multiplication, and division. So that's why on this first problem, we had multiplication. To get rid of it, we used our inverse operations, and we used division to get rid of it. So now we have this sticky note, we can move it around as we solve other problems just to help us remember what we're supposed to do. So now I'm going to rewrite number 2 from the do now. And number 2 was 5 plus x equals 21. Our goal is to get x by itself. We want to get rid of anything that is not x. So on this side of the equal sign, I have 5 plus x. What do I need to get rid of so that x can be alone? The 5. And what operation is 5 doing? It's adding to the x. Is it subtracting? Is it multiplying? Or is it dividing? It's adding 5 plus x. So how would I get rid of adding 5? Subtracting 5. Good. So all I need to do here is minus 5. And 5 minus 5 is 0. So that's going to cancel out. But where else do I need to subtract 5? 21 on the other side of my equal sign. Okay. Now, do we need this plus sign anymore? No, we don't need it because there's no other number here anymore. It's just x. So we don't need that plus sign. So at the next step, I bring down my x, bring down my equals, and 21 minus 5 is 60. Good. Very good. So we've done one where we divide, we've done one where we subtract. Let's see, how about we do one not the same as the do now problem. We're gonna get to that in a minute. How about x over 3 equals 20? What does this mean when I have a fraction like this? What operation is happening to x? Am I adding? Am I subtracting? Am I multiplying? Or is this division? This is division. We can remember division is also like literally the symbol. There's a line and there's 2 dots. Those 2 dots, you can think of those as the numbers. Here's my line, 2 dots, my numbers. So if I want to get rid of divided by 3, how would I do that? We have divide already. What's the opposite? Multiply or times. Oh, I heard you wrong. That's my bad. Very nice. You got it right. Sorry. I swear my hearing is not great. So to get rid of division, we are going to multiply. So I am going to multiply by 3 on this side. Where else do I multiply by 3? This one. On the 20. Gotta do it on both sides. So my 3's cancel out. And I'm left with x all by itself. I bring down my equal sign. And all that's left to do is 20 times 3, which is 60. Good. So we've done one where we divide, we've done one where we subtract, we've done one where we have to multiply. Now let's look at one where we would have to add. So how about do -12 plus x equals 6. Kind of problems can often look really tricky because you see that minus sign on the 12, but you also see a plus sign. So which sign are we looking at? That minus, because we're trying to get x by itself. And that plus sign is really just like an and sign. We have -12 and we have x. So to get rid of -12 or -12, what would we do? We would add it. We would add 12. So I am going to do that. I add 12 to both sides. So, and what happens over here? They cancel. Cancel the 12, get rid of the plus, bring your x down, equal 6 plus 12 is 18. Good. That would be your answer. Okay. So we have looked at a couple of different problems where we have to use all four of the operations. We have any questions about anything that just happened up here? Or is it making sense? Making sense? Okay. So this is what we call a one-step equation because all we've done to solve these is one step. For number one, my one step was that I divided by 2. On number 2, my one step was that I subtracted 5. On number 3, my one step is that I multiplied by 3. Number 4, my one step was that I added 12. We're going to get to equations where there's more than one step, but I want to make sure that we have mastered the one-step equation before doing that. So, let's see. Do you guys feel like, after running through a few of these together, if I gave you some similar to this, think you could do it on your own? You think you could?
Yeah.
Okay, I'm going to give you 4 problems very similar to these. And I want to see if we can get them correct. And if so, I'm going to do a 2-step equation. So I'm going to try these by yourself. First one, I am going to give you plus give you somewhere X is on the other side and see if we can figure them out. Problems. I'm going to come around the room while you work on these, and I'll let you have a little head start to get started on your own. But I will come around and see how we're doing. If anybody needs some help, I can help you. So let me pause this. So number 1, x plus 5 equals 15. How do I solve this? Good, minus 5 on both sides. What happens to my 5s? They cancel. And now what? X equals 15 minus 5 is 10. Good. Number 1, X is 10. Perfect. Number 2, 3 times X equals 9. How do I solve this one? Divide. We're going to divide by 3 on both sides. And my 3's, what happens there? They cancel. So I get X equals 3. 9 divided by 3 is 3. Perfect. Okay, number 3. X divided by 4 equals 3. How do I solve this? Times 4. Multiply by 4 on both sides. The 4's cancel. And X equals 12. Perfect. Perfect. Okay. Number 4, X minus 2 equals 10. How do I solve? Add 2. Good. To both sides. And my 2's cancel. So X equals 12. Good. All right, halfway there. Now we'll look at number 5. 25 equals X plus 1. Now, numbers 5 through 8. I mixed it up on you. I just wanted to see how you would react, see if you could do it. The difference here is now my variable, my X, is on the other side of the equation. This is not going to change anything except for what side it's on. You're still going to do the same option, the same steps. What did you guys do for number 5? Yes, I'm still trying to get X by itself. So I'm going to subtract 1 from both sides, just like normal. And what happens here? The 1's cancel. Bring down my X. Equal. Good. 25 minus 1 is 24. So the only difference here is now I have a number equals X instead of X equals the number. You do the same exact process, it's just flipped around, because you'll see it like this sometimes. It's the same thing. Okay, number 6. 40 equals X minus 10. How do I get X by itself? You said plus 10? Yeah. Perfect. We're going to add 10, plus 10 to both sides. Okay, then what happens? My 10's cancel, and I get 40 plus 10 is what? 50. Bring down my equal sign, bring down my X, 50 equals X.
I got the same answer, but I did 40 plus 1.
You did 40 plus 40? Oh, but that wouldn't give you 50, would
I'm
it?
like on both sides.
Oh, okay. So you would want to be careful with that, because I'm glad you said something. Let's look at what would happen if we did 40 plus 40 on both sides. So for number 6, I'm just going to rewrite it. We have 40 equals X minus 10. So if you add 40 to both sides, like this, is this how you did it? Plus 40, plus 40? Okay. When we go down the line, 40 plus 40, is that going to equal 0? Will that cancel out?
No.
It won't. It's actually going to give us 80. But let's just pretend that we could cancel that. I bring down my X. Negative 10 plus 40 is 50. But I don't have X equals 50. So whenever we get to more complicated problems, we have to be really careful about what spot we're writing things in, because I'm sure it was just kind of automatic thinking, okay, well, X is going to be 50. That makes sense. But we need to make sure that we're keeping everything really nice and lined up. Because let's see what would happen here. You added 40 here, you added 40 here. Oh, but actually, minus 10 plus 40 isn't 50, is it? If it was plus 10 plus 40, it would be 50. Minus 10 plus 40 is actually 30. Let me rewrite that. So what would happen here is to get the answer for x, we would have to get rid of 30 now. We'd have to subtract 30 from both sides. And we would still get a minus 30 is 50 equals x. So you can solve in different ways. This was one where it was like the two mistakes canceled out, so you did get the right answer. It was a lucky one. But in the future, it might not cancel itself out. You might not get lucky on it. So let's make sure we're just practicing being really careful about how we bring things down. Something that I like to kind of teach also is wherever your equal sign is, you could just split it down the middle so you know what side is what. That way you're not getting it mixed up, just to prevent mistakes in the future. But I appreciate you pointing that out because even though it worked this time, it won't work every time. And then you'll end up getting some incorrect answers. So we'll want to be real careful in the future. Let's look at number 7. I'll draw that line down the middle.
Oh.
So I have 12 equals 4 times x, and I need to get x all by itself on this side. So what should I do? Divide by 4. And I did it over here, so I got to do it over there. Bring down my x equals 3. Good. Good. Perfect. Okay. Number 8, last one. 2 equals x divided by 2. How do I get x by itself? Times 2. And my 2's over here with my x will cancel. So x is by itself equals 2 times 2 is 4. Good. Very good. Okay. Now we've done all of them. Did anybody else do any of these problems in a different way or get a different answer for any of them? Or did we really get all the answers right? Got them all right? Every single one? You did? Man, you guys are just too smart. Too smart for me. Okay. Well, let's go to the next thing then. I am going to flip my page. And let me pause this for just a second. So we're going to start another page of notes here. And we're going to move on to 2-step equations. This is where it gets a little bit trickier. So I'm going to title my page. Notes. Page 2 of my notes. We are looking at 2-step equations. But sometimes there is more than one step that we got to take to find our x value. So I'm going to write 2-step equations. Start by giving you an example, from the do now, that number 3 is a good example of a two-step equation. We have 3x plus 1 equals 10. So we'll start with this example here. Now we have more than one operation happening to x. Normally we would just have 3x equals something, or x plus 1 equals something. But now x is not only being multiplied by 3, there's also 1 being added. So there's 2 operations. Now, whenever we're solving equations, notice that we're using inverse operations, opposite operations. So whenever we have more than one operation, normally we would look at the order of operations. But we're doing the opposite. So not only do we have inverse operations, we kind of have inverse order of operations. So luckily, we're really only dealing with these 4 operations. And addition and subtraction get grouped, and so do multiplication and division. So really, there's 2 that we have to worry about. Instead of multiplication and division first, whenever we are solving equations, we do the opposite. We are going to get rid of addition and subtraction first. Then once there's no more addition or subtraction, we can move on to the next step, which is getting rid of multiplication or division. So those are our 2 steps. Now, when we get to when we get to 2-step equations, this is where I really would encourage using the line to separate your equal sign, because it starts to get a little bit more messy when you have more than one step. So for this example, I want to see, is there any addition or subtraction I can get rid of first?
Yes.
There is. What is there? The 1. How do I get rid of plus 1? Subtract 1. We're going to do minus 1 on this side. And also on the other side, under the 10, minus 1. And I'll draw a line. Ones will cancel. And let's see, what's 10 minus 1? 9. I'll bring down my equal sign. Now this time, instead of just bringing down x, we still have 3x. So we bring that down to 3x equals 9. And now we have a whole new equation. That's what we like to think of it as, a whole new equation. We're back to a 1 step. So how do I get x by itself from here? Divide. Yes. This is 3 times x. To get rid of multiplication, we divide. So divide by 3 on both sides. And what happens to my 3's? They cancel. Bring my x down. My equal down. 9 divided by 3. Yes, it's 3. And that would be my answer. So this is a 2-step equation because now there's 2 steps. Step 1 was subtracting 1. Step 2 was dividing by 3. And then we got our answer. So that's our first example. Let's look at that other one that I put on this do now. Let's see, it was x over 5 minus 2 equals 8. We're gonna keep following that order. The order to solve. So for step 1, do I have any addition or subtraction to get rid of?
Yes, yeah.
Yes. What do I need to get rid of?
2.
The minus 2. How do I do that?
Add.
Add 2. Good. So plus 2 on both sides. And what happens to my 2's? They cancel. Okay. I do the next step. We're going to bring x over 5 down. And the equal sign. And 8 plus 2 is 10. Good. So that was step 1. We added 2. And you don't have to label your steps. I'm just doing it for the sake of notes. So we don't have any more addition or subtraction to get rid of, do we? We have multiplication and division though. X divided by 5. How do I get rid of divided by 5? Times 5. On both sides. Okay, so there's my step 2. I multiply by 5.
Yep.
And what happens? 5's cancel. I got x equals 50. Good. X equals 50. Okay. So the only different thing that's happening with the 2-step equation is you got to make sure that you're doing your operations in the right order. You're doing it opposite though. So we're getting rid of addition and subtraction, then multiplication and division. Now that is the kind of simplest version of solving 2-step equations. But let me ask you, what would happen if I had something like, on this worksheet I just passed out, let me grab a copy. These are the answer keys. The 2-step equations worksheet. Look at number 1. This is different than what I just showed you, isn't it? I have 8 plus x divided by 12 equals -1. Now, whenever we have something like this where this whole side of the equation is a fraction, I can't touch the top of a fraction until the fraction doesn't exist anymore. Okay, so this is where we would have an exception to our rules. I can't subtract a from a plus x over 12 because it's not by itself yet. In a scenario like this, we actually need to get rid of divided by 12 first. So, how would I do that? What's the opposite of division? Multiplication. So I'm gonna multiply by 12 here. And I do it to the other side as well, don't I?
Yeah.
Perfect. Okay, and my 12s will cancel. So what do I bring down at the next step here?
The 8 with x.
Yes.
Equals. Well,
Very close. 12 times -1. Correct number, think about the sign now.
negative.
-12. -12. -1 times any number will be the same number, but it'll just become negative.
Because of the -1.
Yes, because of the -1. So now I have 8 plus x equals -12. What do I do now?
I don't know, would you subtract 8?
Yes, you would. You subtract 8. Trying to get x by itself. 8 is being added to x. So we're going to subtract 8. Both sides. You should get a negative. That's right. What answer did you get?
-20.
-20. Perfect. -12. Take away 8. You will get an even bigger negative. -20 will be your answer here. So that's the exception, is whenever our equation is written as a fraction, we have to get rid of the fraction first, the division. That's the only part that can be a little confusing. Look at number 2 on this worksheet. Does anybody still need to see number 1 though? I don't want to jump ahead if we're not ready. Number 2, I have 1 minus 9 times x equals -89. This is tricky. Have you got some negative numbers? And that always makes it a little tougher. Now, we don't have any fractions, so we can follow our regular order of operations for solving equations. Do we have any addition or subtraction to get rid of? Do, don't we? What do we have? We've got that 1. Now, this is a little tricky because even though it's 1 minus 9x, we're subtracting 9x. Are we subtracting 1?
No.
We're not. This is actually a positive 1. We're always looking at the sign that comes before it. And if there's no sign, it's positive. So how do we get rid of positive 1? Yes, with -1 or with -1. We're going to subtract 1 here. -1, -1. So my 1s will cancel. What do I bring down? Yeah, that -9x equals -89 minus 1. Say it again. Almost. Go the other way. If we start with a negative and then we subtract even more, remember that just makes the negative bigger. Yes, it's kind of like you're adding the negatives. So 90, -90. Now I have -9x, or -9 times x, equals -90. What would we do here?
You divide.
Yes, we would divide. Divide by -9 on both sides. Those -9s cancel. So we got it equal 10.
Yep.
Positive 10. The two negatives cancel out. Good. Good.
I forgot that when I was doing that negative. I didn't know that. I just hit it wrong.
Oh, that's all right. That's all right. We're learning. This is the definitely a tricky worksheet. It's tricky. Let's see. Let's look at number 3. For number 3, what do I need to do first? Times 3. Yes. Why are we multiplying first this time?
Oh.
You're correct, by the way.
I thought
That's
it was because we were trying to get that by itself, the top by itself.
That's exactly correct. Yes, we have to get rid of this fraction. We need to get the top by itself. I can't get rid of anything on top of a fraction until the bottom is gone. I need to multiply by 3 on both sides to get rid of that. Now, is anybody confused about why we have to do that? So we can go into a little more detail. Well, just let me know. We can. What comes down? What happens next?
The x minus 3.
The x minus 3. Okay. Equals. Negative 5 times 3 is. Almost. It is negative. You did 4 times 3. What's 5 times 3? Yep, yeah. Negative 15. Okay. Now, what do I do next? Okay. Yes, add 3. Both sides. The 3's cancel.
Yep.
Yes. And I'll bring down x equals negative 15 plus 3. Almost.
It's negative 12.
Negative 12. Remember, if we are adding with different signs, we're really kind of subtracting there. Yes. So negative 12. X equals negative 12. Good. Okay. All right. Let's go through actually and work with all these weird fraction problems. Let's just get used to those. So let's see. We have, I'm going to go through and circle them. Number 4 is fraction problem. Number 8. Number 9. Number 10. Flip to the back. Number 12. Number 15. Number 19. And 20. Okay, so let's do those again. On the back side, it's just number 12, number 15, number 19, and number 20. And on the front, again, one more time, we have number 4, number 8, 9, and 10. So let's look at number 4. This is a problem where we have a big fraction on one side. What would I do first? Times. We're going to times 2. So I'm going to make a little note on this paper specifically. Actually, hang on. I want to put it in our notes because this is one of those things where it might make sense today and then I don't want you to lose it later on. I want you to have it written down. So these are your normal first two steps, but if one side of the equation is a fraction, multiply first to get rid of that fraction. An example on our paper here, and I'm going to use that number 4 that we were about to start working on. Was negative 14 equals x minus 9. All of that over 2. Oops. So I'm going to write the example on our notes here. What did I do first, Ayana? You said multiply
Yes.
by 2.
Yes.
So we'll do that times 2.
Yep.
Cancel out the fraction. Both sides times 2.
Yep.
Okay. And I'll bring everything down. What is negative 14 times positive 2? Negative 28 equals what?
Your x.
X minus 9. So negative 28 equals x minus 9.
Yeah, now you're going to add 9.
Now you get to add 9. Perfect. Both sides.
Yeah.
The 9's cancel. And x equals
I got negative 19.
negative 19. I think that's right. Let me double check it. I have a hard time adding to negatives in my head. Negative 28 plus 9. Yep, negative 19. Your answer. Okay. Do we have any questions about that? It's just the one exception we're going to talk about today. So I'm going to just copy that back onto this worksheet. We just worked it out. But I'm just going to write it again. Okay. Can I move this? So that was number 4. Let's look at number 8. Number 8, what would I do first? We're going to what? We're going to times 18. We got to get rid of that fraction.
Yes.
So we're going to multiply by 18 on both sides. Okay. What happens to my 18s?
They cancel.
They cancel.
So you bring that down. And then 6 plus X.
I've got negative 6 plus x over here. Bring down my equal sign, and what is negative 1 times 18? Negative 18. Perfect. Okay. Now, I get an x by itself from here. Divide. What needs to be divided?
-6.
Negative 6. So I have negative 6 plus x.
Oh, well, then
Hmm.
add 6.
Yeah, so really, there's a couple of things we could do. We're adding negative 6. So we could subtract negative 6, which is the same thing as adding positive 6. But the thing that I think makes it a little bit less confusing is just look at whatever sign is right in front of the number. I have negative 6 and I have x. I want x to be by itself, so I just need to get rid of negative 6. And negative 6 plus 6 is 0. So that would get rid of it for us, right? Mm-hmm. So we're going to add 6 here. And we're going to do the same thing to negative 18. Bring your x down. They're equal. And negative 18 plus 6. Negative 12. Okay. One more with you guys. 9. Now I want you to try a few of these on your own. So for number 9, I have 7 equals 1 plus x, all of that divided by 3. Do you have any idea what we might do first?
You gotta subtract.
Subtract 1?
Yeah.
So normally, yes, you would subtract 1. But this is one of those exception problems because this whole side of the equation is a fraction, isn't it? So we will be subtracting 1, but we can't do it while it is on top of the fraction. We have to get rid of the fraction first. So how can I get rid of this fraction? We have to divide it by 3. So you times 3. We're going to do that opposite. So I'm taking this whole thing times 3. And I gotta do it to the other side too. Yes. So my 3's cancel. And now I can bring down 1 plus x. Yeah, 7 times 3 is 21. So we have to get rid of the fraction first. Then we can subtract 1. So now let's do the step that you gave us. We're going to subtract 1, both sides. Bring that X down. Equal 20. Good. X equals 20. Okay. Number 9. Now, did I tell you guys how to check your answers? How to plug this back in
Yeah, okay.
on the calculator? I'm going to show you again, just so if you get an answer and you're like, I don't know if I did that right, you can always be sure by checking this way. So I'm going to look back at my original problem. My original problem was 7 equals 1 plus, now I'm going to leave a space for x, 1 plus x divided by 3. We just found out that x is 20, right? So I'm going to plug that in instead of x. Now, whenever we have a fraction, it's like having this part in parentheses. You have to do that first. So let's go through and see if it works. What is 1 plus 20? 21. Bring everything down. And what's 21 divided by 3?
11.
You said 11?
7.
Oh, 7. And does 7 equal 7?
Yeah.
It does.
Is that
7 is the same thing as 7. Yeah, 7 equals 7. So 20 is correct.
Yeah.
That's how we know it works. As long as we end up with a true statement. That's what we're trying to find, is what number can I put in for x so that this is a true statement. That means all of this together equals 7. And all of that together did equal 7. So it's true. It works. Okay, we're at about the point in the class where I would normally give you guys a break, and I'm going to give you guys a break. So let's take like 15 and come back around 2:30. And we'll talk some more about this. I want to make sure we're all getting it. So I will pause our recording, and we'll come back in a few minutes. Okay, so we are back, and we are on number 10 now. This is another one where we have one side of the equation all in a fraction. So what do I have to do first for number 10? Get rid of that 3, right? Okay, so how do I get rid of divided by 3? Times 3. Good. So I'm going to do times 3. And I'm going to do it on the other side as well. Yes, it do. My 3's over here cancel. And what gets brought down? Good. Negative 8 plus x equals 3 times 3 is 9. Okay, one more step. What do? Add 8 plus 8 plus 8. Negative 8 and plus 8 cancel. Bring down my x equals 9 plus 8. 17. Good. Good. Okay, so did a whole bunch of these. On the back of this worksheet, there are a few circled. That's number 12, number 15, number 19, and number 20. Okay, I want you guys to try these on your own.
What?
Number 12, here, I'll write it down so we can kind of see it all in one place. Number 12, number 15, 19, and 20. And these will all be the same. We get rid of the fraction first, then we can get rid of what's on top of it. So, I'll pause our thing one more time. I'll let you guys get to it. Okay, so our timer just went off. And I'm going to start with number 12. For number 12, I want each of you to tell me what answer you got for X. I'm going to write all of them down. You got negative 18. Did you two get anything different than that?
I didn't do number 12. I skipped it.
I got you. What did you get
And I was at 15.
for number 12? For your answer. You got negative 12. Okay, negative 12, negative 18. So let's see which one is right. So on number 12, what is the first step we should take? My 2. Now, am I subtracting 2 or am I multiplying 2?
What's the try?
Oh, okay, this is where we get mixed up. Whenever we have a fraction, this is the only time we have an exception to the rules. So if it was just 2 plus x equals 8, or the negative 8, then yes, we would subtract 2 first. But we have a fraction. Gotta get rid of the fraction first. So we're going to multiply by 2 first. That's the exception rule. So let's multiply by 2. And let's see. My 2's will cancel. And see, I'm multiplying by 2. So what is 2 times negative 8? Yes, negative 16. Now we're gonna bring it down equals 2 plus x.
Yes.
Okay, so now we can subtract that too, can't we?
Yeah.
So minus 2, minus 2.
2's kids.
My 2's cancel. I'll bring my x down, my equals down. Now I have negative 16 minus 2. What is that going to give me?
Negative 18.
Negative 18. Okay, so another way we can check our answers, because let's say we did get negative 12. First of all, I think the way we would have possibly gotten negative 12 is maybe we subtracted 2 first, and then we thought, oh, 8 minus 2, that's probably negative 6. It's actually negative 10. That's okay. And then multiply by 2, and that would give you that negative 12. So it makes sense. But here's how we can check our answers. We're going to do that same thing where we plug it in and see if it worked. So we just solved and got x equals negative 18. We know that that's going to work. But let's see what happens when we plug in an incorrect answer. So what I'm going to do is I'm going to rewrite this whole equation, but I'm going to leave a space for x. So I have negative 8 equals 2 plus x divided by 2. And let's put negative 12 in there. Okay. So I want, first of all, if we have a fraction, we have to do what's on top first. So let's start with that 2 plus negative 12. What would that give us?
But what?
2 plus -12. What is that?
-10.
-10. Okay, so I have -10. And that's still over 2 equals -8. So I'm going to cross that off. I'm done with it. Now, over here, -10. What'd you say?
So you still multiplying or
Now we have a division problem. We're not solving anymore. We're seeing if this is correct. So we plugged in that -12 to see what would happen if I put in an answer that isn't correct, and I'll show you how we know it's not correct. So now I have -10 divided by 2, and what is that? -5. So I end up with -5, that's equal -8. So now we have to ask ourselves, is -8 equal to -5? Are those the same? No. So if you plug your answer back in for x and you get a number is equal to a number that is not the same, then you know x is not correct and we need to go back and check to see if there's something we can do different. So that's how we know x is not equal to -12. If we plugged in that -18, we would get the right answer. Okay. So that was number 12. How about number 15? What answers did you guys get for number 15? -11. You all three got -11. Okay, let's see if it's right. What do I do first?
That's pretty good 10.
Yes, we got to get rid of that 10. So we'll multiply by 10 on both sides.
10's cancel.
10's cancel. -9 plus x equals -20. Good. Yeah. 9 to cancel them.
Yep.
Perfect. We get x equals
-11.
-11. Yes. Perfect. You guys, that's wonderful. Okay, so we all got number 15. That's good. Let's look at number 19. What answer did you get for x for 19?
It's 14.
You all got 14. Yes. Let's see. What'd you do first?
I do with a 10.
Yep, we got rid of 10. Multiply by 10.
And 10's cancel.
My 10's cancel.
Got the x minus 4.
X minus 4 equals 10.
Yep, you add 4.
Then you add 4. Yes. Of course, cancel. X equals 14. Good. Good. Awesome. Okay, we got that. And last one, let's look at number 20. What'd you guys get for that?
I can make a 5. I ain't gonna do that.
Okay, I appreciate the honesty. So we got 2 -5s and 2 I didn't do it. That's okay. Or 1 I didn't do it. That's all right. That's all right. Let's do it now. What do I do first?
Gotta get rid of the 5.
Gotta get rid of the 5. Well, there's 2 5s. Which one?
5.
The 5. Yes. That fraction. So how do I get rid of that? Times 5. Okay.
You 5 cancel.
My 5's cancel.
Get -10.
-10 equals
Your x minus 5.
x minus 5.
You add your 5.
Then you add 5. They cancel. Good. And what do we have?
5. Make it 5.
Yes, -10 plus 5. That is -5. Bring our equal down. Bring our x down. -5's x. Good. Is it starting to feel a little bit easier?
Yeah.
Just a little bit. It's repetition. It's so annoying to do the same kind of thing over and over and over, but when you do that, it starts to click, and then you start to get it better. So that's why we do it that way. Good. Okay, now remember, that is the exception, is when it's a fraction. And in any other kind of problem, we do the addition and subtraction first. So that can be tricky to keep straight in your mind. It totally can. But, keep your notes, be diligent about being careful about each step. Not ever a bad idea to check your answer. But yeah, there's a couple of those. But let's just make sure before I give you an exit ticket, let's make sure we know what to do on one that isn't a fraction. Let's look at number 17. This one's different. 41 equals 9 times x plus 5.
It's good trying to get x by itself, right?
I am always trying to get that x by itself.
Well, I think what you would have to do, I don't know, but I had it added 5. I just looking at the 5.
Yes, we want to subtract 5. Because when we're solving an equation, unless it's a fraction, that's the only exception, we want to get rid of addition and subtraction first. So, minus 5 on both sides. All right?
Cancel 5.
Yes, cancel the 5s. Then what?
Bring my notes down.
Bring down 9x. Well,
What we're gonna find is 36.
36.
And this
Okay.
is where you divide.
Yes, now you divide. Now we have 9 times x equals 36, or I said it backwards, but you see it. What do I do?
Divide 9.
Divide 9.
Yeah. The 9's cancel, bring up your x. I got 4.
X equals 4. 4. Good. That's perfect. Perfect. So that's probably the most difficult part about this topic is remembering when to multiply and divide first, when to not, when to do addition and subtraction first. Just remember, you're always doing addition and subtraction first, unless it's a big fraction. That's the only time you do your multiplication first. Okay. So I have an exit ticket for you. I already have copies. I will pass these around to you, but it's going to be 3 problems. And little hints to help you. Number 1, this is a big fraction, okay? Number 2, not a big fraction, regular rules. Number 3, not a big fraction, regular rules, okay? So, number 1 is the special one. 2 and 3, you do them like normal, where addition and subtraction come first.
Okay, you take the money.
Yep, those you can keep. I have it written down as an assignment because, well, long story short, whenever I started having everybody turn in their worksheets, I had 30 students in my other class. And I ended up having too many things to grade, and since I watched you do them, you're gonna get your credit for it because you were here. If you were not here, which you guys aren't, but anybody listening on the video, if you're not here, you do have to do this worksheet and turn it in. So, this is the exit ticket. I'm gonna pass it to you guys, and that is it for today.